All right. I am really excited to be here with Rajat Bhageria, who I met in person, I think, Rajat, maybe 6 years ago in San Francisco. We had an event about food robotics. At the time, you were very stealthy, but now you're coming out
Yes.
into the open. How you doing, Rajat?
I'm great. Thank you so much for having me, Michael. I'm excited to chat.
Yeah, at the time you were on a panel at our event called Articulate, as a food robotics event, and you were kind of more positioned as an investor,
Yeah.
stealthily building your own company, Chef Robotics. And so you have some news, which we're going to jump into. But before we get into that, let's learn a little bit about you. I was just looking at your LinkedIn. I didn't know you were a writer for Forbes. You did some writing for HuffPo. Like, how did you go from like writing about being a startup entrepreneur to maybe that is a natural transition, as I say it. But
Yeah.
how did you go from that to what you're doing now?
Yeah. I think it's interesting. So I think I've always been interested in kind of inventing things, and I've always been interested in business and kind of the combination of the two. So I started my first kind of like company project almost actually in high school. At the time, it was kind of a very small thing, but it was kind of a social network for like young people to share their writing with the world.
Oh, cool.
And this is because I had done some scientific research in high school, and I was able to get published, which is kind of very I would say I got lucky, right? But a lot of my peers who were doing research or they're writing their own like whatever creative writing or poetry weren't able to do that. So I think I got really into like startups, which is kind of what helped with that social network. But I also was into writing, which is kind of the whole point of that system. It was kind of Medium before Medium became a thing. And then in college and grad school, I started a company with a few friends called Third Eye, where we were using computer vision to essentially recognize what's in front of you for the visually impaired. And I think this was kind of like early days of like object recognition. Deep learning was still, it felt like it's had its moment with
Yeah,
AlexNet.
yeah, yeah.
And, we were like, what if we use smart glasses like Google Glass and otherwise to kind of recognize what's in front of you? Anyways, we did this startup, and this was also the time when like Teal Fellowship was starting to really kind of have its moment. And a lot of my friends
Yeah.
were considering dropping out or dropping out. And,
And
I think
what
Michael's
about circa what time was this?
like 2014 or so, I'd say.
2014. Okay.
Yeah. I think, for, various reasons, parents and otherwise, I think my co-founders and I for Third Eye, we were all kind of hesitant to drop out. I think we wanted to kind of stay in at least college and finish that out. So I became really excited. Okay, well, like I'm really interested in writing. What if I wrote about like how do I build a startup during college and grad school, right? So that became something kind of differentiated and like something different than a lot of other people weren't writing about, and that's kind of how that happened. And writing actually was kind of it's always been something I really enjoy. It's like on a Saturday or Sunday, it's nice to just like
Yeah.
get into the moment and spend whatever 5-6 hours of like deep focused time to like get your thoughts out and edit it and make it refine it. So I've
Yeah.
always enjoyed
Yeah.
that.
Yeah. So that's really interesting. You were getting published in high school, that's pretty impressive. Then you did a startup around social networks oriented around writing, it sounds like. And then the Thiel Fellowship, the whole purpose of that, like the thesis behind that, is my understanding, and correct me if I'm wrong, is like, you don't need to go to college, young founder,
Right.
just to go start a business, right? And so he would
Yes.
provide startup funding to do that.
Yes, exactly. And I think there's some truth to this, right? There has been some Teal Fellows that have been very successful, and I actually think there's some merit to that. I'm actually pretty close with many of the people in the community. I think I've always been very excited about deep tech, and like like obviously robotics is a deep technical product and company, and I think like for that kind of like, so robotics, like what is it? It's basically like math, and it's a linear algebra and
Yeah.
calculus and statistics and
Math and physics and mechanical
yeah,
engineering
yeah.
and all that stuff.
Exactly. And AI, like what people consider as AI, is basically matrices being multiplied over and over, essentially, right? So, anyways, I was pretty like, aware enough to say, okay, like I want to do something in deep tech, which requires like some pretty good computer science and math skills, essentially. So, college and even grad school kind of made sense for me, which is why I decided to kind of stay. So, I was excited about kind of touting and kind of talking about this idea that you can do something pretty cool while still remaining in college and grad school, and actually might be an asset because you have skills that people like. For example, now like if I got my master's in AI and robotics, I kind of did that in my senior year of Penn, and that's been very helpful, I would say, because I think like I can talk to like engineers, I can talk to investors, and be like, hey,
Yeah.
I can speak your language, and I'm
Yeah. I
credible.
mean,
I'm not. Yeah.
I mean, I don't know how you could be a true deep tech technical founder. Most people can't just learning off of YouTube. I think,
Yeah.
like
Yeah.
staying in a school like Penn and getting
Yes.
that technical foundation, I think is
Yes.
hugely important for a technical
It's very
co-founder.
important. It's very important, and I think here's what's interesting, right? So like, what's interesting is that it's still kind of the difference between programming and computer science, I would say, or like CAD and mechanical engineering, if you know what I mean. Like in the sense that anyone can learn how to program or do CAD, if you will, on the internet. And you can build a wrapper on top of like some off the shelf model, and that's fine, right? And that is something that's, by the way, useful, right? Like we need people who can do that. At the same time, if you're inventing something novel, just putting that wrapper on top of something is not going to be how you have something very fundamental. I think to have something very fundamental, you do need to understand the math. You do need to understand kind of what's happening a little bit more deeply, I would say, and that's
Yeah,
where
and
that I
then
think courses help.
yeah, and maybe there's the genius few and far between that does that. Maybe like a Bill Gates or Zuckerberg can quit college and do something crazy, but like I think
Yes.
most people need to get that training. But so,
Yeah.
you're getting this college, you graduate from Penn, great college, by the way, and then you pretty rapidly move into building companies. And I think 4 years after college, when I got together with you in San Francisco, you were already investing in food tech. So how did you make this
Yes.
rapid transition to starting a robotics startup and then also being an investor?
Yeah, yeah. So I think what Third Eye taught me, which was again in college and grad school, was that
Hmm.
I think what it taught me, and we can talk about the Third Eye experience more, but I think one of the learnings I've had is that I did realize that computer vision and AI is going to be immensely powerful. I mean, I think even this was like, again, back in 2014. Like, again, it's not a crazy big realization in hindsight, but at the time it was like, this is, I think, the one of the things that's going to affect our lives more than anything else. Because, and here's why, right? For forever, getting information from the physical world into the computer, like sensing the world, was really hard. So now you have really cheap cameras, right? We have really cheap compute GPUs hosted in the cloud. You also have really good algorithms like deep learning, and of course nowadays transformers. Of course, at the time transformers weren't really much of a thing, but it became really clear that suddenly you can make sense of the physical world and get data into the physical world. And once you can make sense of the physical world, you can actuate the physical world, right? I can pick things. I can drive a car. I can drive a plane. I can do these really cool things. And I became very convinced that the biggest impact of AI would be on the physical world, which is by the way, like
Yeah.
again, it's not something that's it's somewhat obvious, maybe sometimes not obvious, because Silicon Valley has made its money in more recent times in software. Silicon Valley is founded on hardware with this integrated circuit with Intel and stuff, right? But as of late, it's made its money in software, and this idea that like AI's biggest impact will be on foundational industries like transportation, manufacturing, food and beverage, insurance, these foundational industries, um, was kind of what I was excited about, right? And
Yeah.
the next question I really had is, okay, like what's the right kind of market for AI plus, basically embodied AI, right? And I kind of became convinced on a broad strokes level, I became convinced it's the labor market, which it's kind of a simple idea, which is the biggest industry on planet Earth is the labor market at $45 trillion in GDP. And then it was a question of, okay, what's the right industry within that?
Yeah.
Um,
Yeah.
that's where the fund Prototype Capital, I think, kind of helped me. Now, the fun story is kind of like, after kind of this master's in robotics and AI, like a friend and I were, one of my closest friend, indeed, we were just chatting, and uh, we basically both agreed on this kind of high level hypothesis thesis, right? Which is the biggest impact that technology companies can have is take a new technology and apply it to a very old industry. And
Mm.
our differentiation was that, okay, like a lot of the people who are building these companies, and perhaps the people who are building the companies where the founders are, but also the people who have access to proprietary data sets, because that's what AI is all about, and also the people who really understand the nuances. They're oftentimes not just in the Bay Area or LA or New York or Boston. They're everywhere else. They're in Cincinnati, Atlanta, and Des Moines, everywhere else in the country. So how do we get those people? And our kind of general hypothesis was that founders hang out with other founders. It's just, birds of a feather,
Yep.
tend to hang out. So if I can find really, really awesome founders in Cincinnati and I can bring them on as kind of essentially a scout, and give them some carried interest in the deals they bring in that are successful, then I can try to have a really good set of deal flow coming in these foundational industries. So that's essentially what we did, right? We had kind of
That was a
70 plus founders.
That's a great working thesis. I mean, I think so many times people will sit in San Francisco and wait for the deals to come to them. And like you said,
Yes.
you go to Chicago, you go to Cleveland, you go to
Yes.
Baltimore. There's so many people in these old world industries that have this
Yes.
deep institutional knowledge. They may have access to great data sets. And so
Yes.
you're putting those scouts out. And so it sounds like you've built a pretty big portfolio. And we're going to get to
Yes.
the story of Chef Robotics, by the way, but you've built a pretty big investment portfolio. By the way, that's a
Yes.
super early age. How did
Yeah.
you go and to some corporate strategics to say, hey, we have this vision and
Yeah.
someone bought into it?
Yeah. I think there's a few things that we had going for us. So on my side, I think what I brought to the table is, I had done a few startups. I did kind of have some of the media part of it. I'd done a lot of writing, right? So, but I think I'd done Third Eye, and Third Eye didn't have some crazy exit, but it did have a small exit. So I think that helped a little bit at least. Then my co-founder, Indeed, while I was kind of hustling in college or grad school to do startups, he was hustling at different VC funds. So he went to UCLA, and he kind of was able to get into and work alongside some really great
Oh, wow.
early kind of Silicon Beach funds, basically.
The marriage of UCLA and Penn, just like that combination, that's a great
Right.
combo.
It's a good combination. So and then honestly, we kind of our whole kind of ethos was founders investing in founders. So he was actually working on his own company at the time. I was kind of like in the early, again, Chef wasn't really founded as of per se, but early days of kind of thinking about Chef. And the whole ethos was like founders investing in other founders. And so we kind of used our age kind of as an asset as opposed to a hindrance. And after that, honestly, was hustling, right? Like a lot of like we talked to hundreds of potential LPs. We were very young, right? Extremely young. We were 21 and 23 at the time, and so we talked to literally
That's
anybody
super
we could
young,
talk to.
but that's so differentiated, right? Like it's so many
Yes,
gray hairs in the world of VC, which
yes,
often could be an asset, but
yes,
I can see where people would young founders would want to talk to you.
yes, exactly. And finally, like one fund took a bet on us. So Airwing Ventures, which is actually a Wharton alum. So the managing partner used to be the managing director of Disney's fund, Steamboat Ventures. So he had a few wins there, and he had this exact same thesis, right? Like foundational industries, old industries, so to say, middle America, all these kind of things that traditional Silicon Valley people kind of sneeze at, right? And we said, okay, like, we basically were able to convince him, and he kind of allowed us to kind of bootstrap that first fund, get it up and running. And then of course, and of course, he was also a good mentor. I do think venture is a bit of a mentor. It's kind of an apprentice model. So he became actually a really good mentor as well. But anyways, we made a bunch of investments, and there's more to the prototype story, of course. But I think from the Chef story perspective, what that kind of experience really allowed me to learn is it really allowed me to talk to a lot of different potential customers, right? And this is not just in the food industry. I try to talk to people in general manufacturing. I try to talk to people in mining and agriculture, of course, in food. Also people in trucking and just really these, again, traditional industries, and just talk to them about their problem and what they're facing. And of course, from that, I decided food, and we can talk about that more. But that's kind of how the prototype experience led to Chef.
But knocking on those doors of people in innovation and big food, like if you just go knock on the door of someone who's in a senior level at Mars or Kraft
Yeah,
Heinz, like
yeah,
they oftentimes won't take those meetings. Maybe they
yeah.
will, but I mean, was it hard getting in those? What was the pitch?
Yeah, that's a good question. I mean, I think there was some kind of macro research we had done to make ourselves seem credible, right?
Mm,
So
mm,
I think I also try to do some of this like high level industry research before even having those conversations, which is to say, like I learned some interesting things. So one thing I learned is that, and part of the reason we decided the food industry is that the food industry is actually the third biggest kind of labor force by
yeah.
number of humans in the country. The only ones that are bigger than that are retail salespeople and nursing aides and personal aides. So, anyways, that was, I had that sense that it's like there's a big number of, like, if you think of like the market size of AI as the number of humans who do that job, right? I was like, okay, the food industry makes sense. Then I
Mm,
also had some data to support that which is that the BLS reported, at least in 2022 and 2023, that the food preparation industry had the number one labor shortage in the country, more than trucking, more than logistics, more than warehousing, at 1.1 million people. And then the third piece of information I had is that and this was actually not obvious, but I learned that food assembly and plating is actually a lot more labor intensive than prepping and cooking. And just
Hmm.
to kind of like put those words into context for people who might not know, like most commercial kitchens broadly, this is kind of bucketing things a little bit, right? But broadly, they'll divide their operation into prep, cook, and plate. Where prep is things like washing the ingredients, cutting the ingredients. Cook might be, of course, cooking in whatever method is necessary. And then you have plating, which is this act of taking pre-cut and pre-cooked material ingredients that's in kind of a hotel pan, a Cambro tub, something like that, into an individual customer's container or burrito or
Hmm.
wrap or
Yep.
sandwich or what have you. And of course, you got to get the right portion size and place it into the right, aesthetically pleasing part of the container. What I learned is actually that counter to what one might think, except, and this is not true for fine dining, by the way, but counter to what one may think, prepping and cooking actually scales pretty sublinearly, and so it's actually not that expensive. Because cooking you can actually do in bulk. One person can cook for 50 people, 100 people.
Yeah.
Same thing for prep, actually, but there's a different context there. There's a lot of traditional automation in the form of like food processing, robocoups, things like that, that works pretty well. So
Yeah. Yeah.
while prep and cook do have humans associated, the number of humans is usually not that high. Usually when
So,
we, and yeah, go ahead.
so the gains from automating the prep and the cook are less so than if you
Oh,
were to
less.
fully automate or
Yes.
automate more the
Yes.
plating.
That's right. That's right. And exactly, which is to say, like, I mean, if you think about like burger flipping or like frying, right? The issue with that business model, like the cook business model, is like how many people are at the grill? One. Or how many people at the fryer? One. Because one person can cook burgers for lots of people. Now, the pitch of robotics somebody says, hey, like you don't need Bob on the grill anymore. But the thing is, robots fail from time to time. They're not perfect. So you still kind of need Bob to oversee the robot. So you didn't really save any labor because there's only a single person
Right.
on doing the cooking. But on the other hand, assembly, and this is true for fast casuals, ghost kitchens, food trucks, food manufacturing, airline catering, everything except fine dining, basically. Assembly scales linearly with output and throughput. So you actually have a lot more humans who are doing assembly. So if I can
Mm.
say, hey, look, instead of having Sally can go to do something else. You still might have a couple of humans doing the assembly or plating, but you can actually save labor. So and because you can save labor, because there's a shortage of labor, you can
Yeah.
actually help them increase volume and revenue. So, anyways, I kind of a bit of a tangential
No,
point,
no,
but
it's a great thesis. It's really interesting. I think if I'm looking in the back of a McDonald's or a Burger King
yeah,
or whatever, there's usually like one person flipping and there's one person
yes,
at the fry station, but there's a lot of people running around and they're
yes,
just assembling the bags to put out to
yes,
the drive-through, bring out to the
that's right,
counter. So it
that's right.
checks.
That's right. That's right. And again, I learned that this scales for literally everybody. So at the time, of course, there's some news we'll talk about, which is like the space we're in, which is a little bit different than most people think. But at the time, I was talking to anybody in food I could talk to. I was talking to food truck operators. I was talking to restaurant, like fine dining operators. I was talking to fast casual operators.
Putting your interview skills to work, the journal
Right.
skills to work.
Yes, exactly, right. And I was just talking to them about their problems. So and basically, I was doing my industry research about like these macro Bureau for Labor Statistics trends, which I alluded to earlier. I was doing this kind of like anecdotal interviewing, like what's your pain points, and and that's and I think the way, and now to kind of finally answer your question, the way to get into those companies is to seem credible, like you've done your homework. Like, hey, look, company, I know that the biggest problem you face right now is labor shortage. Because of that, I know that you probably are leaving revenue on the table. I know that probably the biggest part of the labor shortage is in food assembly. I have this background in AI robotics. Here's something I've done. I'm thinking about starting a new company in the space. I'd love to talk to you for 20 minutes or come by your operation, come by your facility, and just learn more about the problems you're facing. And assuming it's a good fit, I can build you a solution that's really, really for you, like without using the word custom, but basically like designed for you.
Mm, yeah.
And I did that for a bunch of different kind of firms, and that's kind of how you're able to kind of get into the door and kind of listen to their feedback and really build something that they actually want. And we tried to do this essentially idea of like selling the product before building it. And
Mm,
I think that's actually really critical in robotics, because I think robotics and AI has all these extremely technical people and they can build some really cool stuff. but they can't convince a customer to buy something they don't want. So our approach was to kind of flip that and say, okay, look, like technology is not easy, but there's a lot of really smart engineers. We can probably figure that out. What I can't figure out is the customer centricity.
Yeah,
So
yeah,
we started to start with the customer, basically.
that makes a lot of sense. And because you can't put a big giant robot in a pre-built restaurant that has a limited
Yes.
space. I mean,
Yes.
that's what I see where I'm seeing success, right? So
Yes.
it sounds like you're similar in a way to the thinking of a Japanese company called Tech Magic, who you may be familiar with, where they're doing work with, KFC in Japan. They're doing work with some
Yeah.
of the biggest noodle. They're doing it and across both food
Yeah.
manufacturing and
Yeah.
restaurants.
Yes.
They're talking to it. And so it sounds like you were doing some of the same things. And so do you have some of these clients that you've built robots for or are already building robots for?
Yeah, exactly. So I think, it's, and I think this kind of leads well to the kind of news we're announcing, which is, we've been in stealth for a few years now. And the main reason is that
6 or 7 years.
yeah. Well, we started thinking about the company 6 or 7 years ago. I think formal founding was like 4.5, 5 years, I would say, something
Okay.
like that.
Okay.
We started to think about it, of course, but like, actually really, nose to the grindstone working on it was 4.5, 5 years. Yeah. So the reason for this, by the way, is because we feel like we found a sector, a go-to-market that nobody else was really thinking about, which is food manufacturing and food production, right? I think everybody in Silicon Valley and Boston, and really around the country, has been really focused on restaurants, restaurant robotics. And there's many examples of this, right? There's people who make their own robot restaurants and compete with other restaurants. There's people who sell to restaurants, whether they're doing cooking or prepping or assembly. I think that model's hard, and we can talk about that for a few different reasons. I would say the overview, in my opinion, why it's hard is that a restaurant is not doing that much volume. They might be doing a few hundred meals per day. So what does that mean? If you're doing a few hundred meals per day, each job is very generalized. So Sally, who works at Name Your Fast Casual, Sally is doing assembly on the make line. She is doing cutting. She's doing cooking. She's cleaning the floors. She's cleaning the bathroom. She's taking customer orders. If I want to have a Sally equivalent, right, which is kind of what robotics as a service entails, I essentially need AGI, which doesn't exist.
Yeah.
But that's only because volume is very low, right? And I think our insight was that if volume is very high, if you're making not 100 or 500 meals, but let's say 10,000 meals a day, then jobs tend to become more specialized, which is to say Sally's on the assembly line doing plating. She's not doing cutting because there's a separate prep team. She's not doing sanitation because there's a separate sanitation team. She's not doing facilities because there's a separate facilities team. So essentially we realized that actually, like, if we could find a customer segment where the volume is high, the jobs become more specialized. If the jobs become more specialized, then the number of ingredients we have to do to add value to these customers, right? The kind of the generalizability of the tasks that you have to do to add value is smaller, which is really important for AI, I would say, because and this is kind of getting into that small technical weed, but the reason is that when it comes to food manipulation, there's no off-the-shelf training data you can download from the internet. You can't just go to like the open internet and download it as an LLM company might do. Or you can't use simulation like a self-driving car company might do, or a rigid body bin picking company might do, because food is deformable and it's wet and it's sticky. So simulation doesn't work, and also internet doesn't work. You have to go get the data in the physical world. The lab environment also doesn't work because you can make a system that like picks your chopped onions in the lab, but then you go to a customer environment, those onions are completely differently cut differently because there's a new temp worker who came in because the previous temp worker left, or it just changes so much. So we learned that we learned that to really get production data, which is what you need to train your AI, you need to find the fastest path to getting some robots in the field. And if I wanted to get a robot into the field in a restaurant, I got to do every task under the sun. And if I cannot do every task, I'm not generating at least a human worth of ROI. It's like 1 or 0. Are you generating at least one human's worth of ROI, or are you not? And we learned that, okay, in fast casuals, in low volume operations, that's really tough. But if I can go to a high volume operation, then with a small set of tasks or ingredients, I can add value. And therefore, I can ship some robots to production. If I can ship some robots to production, then I get some real world training data. And if I get real world training data, now my food manipulation AI gets better. And if my food manipulation AI gets better, then my robots will be utilized more. And if my robots are utilized more, then the customer is going to want more robots because their robot workers are well utilized. And then if my robot workers are utilized, they get the cycle continues. And by the way, when I go to my next customer, I can already do their ingredients. So, but that next customer's ingredients have a little bit of nuance. They cut their diced chicken a little bit differently, or they sauce their rice a little bit differently. So we get even more diverse data set, and this flywheel continues. And that's the thing we said, okay, like this is exciting, which is when manufacturing is a really awesome go-to-market for food manipulation. And over time, by the way, as the AI gets better, we can go to lower and lower volume operations. So we can start in kind of high mix, high volume, right, which is kind of what we're doing right now. Over time, you can go to high mix and slightly lower volume, which is things like ghost kitchens, right? And kind of delivery only operations. And then finally, fast casuals and prisons and hotels and universities and things like that.
I was going to say, like, the analogy may be, okay, you beat the chicken and the egg problem. Then you talked a little bit about circle of life, but really it's the cold start problem you figured out early on. You kind of got over that big data cold start issue, and that was going to high volume manufacturing. And when we're talking about manufacturing, are we talking about like a CPG product, or like what are we talking about when we're talking about food manufacturing?
Yeah. It's a great question. So, and this is not obvious, right? Because when most people think about food manufacturing, like almost everyone, I'm sure you have as well, like has seen these kind of how it works videos, right? On the TV show, and like there's these like super kind of fully processed lines, right? What you'll find is that there is a big segment of manufacturing that works that way, right? And that's called low mix manufacturing. What that essentially means is that you have 10 SKUs. I made up 10, but a small number of SKUs. So if I think about like Kraft Heinz, right? They have like their ketchup line and their mustard line and et cetera. And essentially they go to a systems integrator and they get a dedicated kind of machine basically. And it only does ketchup. And it only does like the 2-ounce ketchup, right? Whatever the bottle size is. And if you put a 1-ounce bottle, it's not going to work because it's a machine. It doesn't really have very intelligent sensors or decision making. It's essentially doing the same thing over and over again. Another example outside of food might be Apple, right? Apple has the iPhone 15 line, and then it has the Mac line. But the Mac line can't make the iPads, right? They're dedicated custom lines. Each line is kind of custom built for some kind of operation, right?
Earlier generation industrial automation, which has been around for decades. That's right. What this is for. And we've seen the giant mixing vats and then the conveyor belts dropping it into we've all seen those videos.
Yeah, exactly. And maybe I can even share my screen really quickly and show you this is kind of like existing kind of like how it works. So this is kind of the low mix manufacturing environment, right? So this is what most people think manufacturing looks like. And again, to be clear, this is part of how manufacturing looks like, which is low mix manufacturing. Right, but you'll see that this line can only do this kind of ice cream cone or this kind of ice cream. If you put a different kind, it's going to require customization, custom hardware, custom firmware. Same thing with these cupcakes. That's the only thing it does. Or this bottling line, it cannot do a slightly wider bottle. It's not flexible, right? Well, there's this other kind of manufacturing, which is high mix manufacturing. High mix is when essentially you have, and I'll reshare my screen, but just to talk about it a little bit, high mix is when you have a lot of different SKUs. So think about a meal. If I have dinner, I don't want the same dinner every day, right? And I'm vegetarian, by the way, and there's some other people who are meat lovers, and there's some other people that are vegan, and some people that are gluten-free. And in each of those segments, like the meat lovers category, there's like 20 different kinds of meals. So the point is that like if you have a meal, there's a lot of different dedicated SKUs. There's just a lot of different kinds of meals because humans want variety when they have their breakfast, lunch, and dinner. So what does that mean? If I have 100 different SKUs, I'm not going to set up 100 dedicated custom lines because those lines are going to have low utilization because those lines are just going to be sitting around basically.
The CapEx would just be way too high.
Yeah, the CapEx would be way too high. And by the way, it requires real estate, which I don't have, and it's very expensive and all these things. So what do you do instead? What you do is you get flexible lines. So instead of having a bunch of machinery, you have a flat conveyor and you basically have people scooping ingredients and the way it looks is extremely manual. So maybe I can show you another kind of
Yeah.
slide here.
And for
So
the audio only podcast listeners, you're going to have to go to the Spoon to check out the video. We'll put it on the Spoon. So
yeah. So this is kind of what Highmix actually looks like, right? Which is an extremely kind of manual operation, right? It's a lot more manual than most people imagine. It's basically these long assembly lines where people are
so a lot of
scooping.
the products we're talking about are like maybe meal kits, um, ready to assemble meals from Costco and those types of things. That's the type of thing we're talking
Um,
about.
well,
Or am
it's
I?
basically any kind of meal. So okay, so let me give you a few examples. So meals that you might have in a hospital system, so like Kaiser and others,
Okay.
right? These are actually made in this way. Meals that you might have in an airplane, meals that you might have at the airport,
Got it.
um, meals that are delivered to you from these delivery companies like Sunbasket and others, Factor and otherwise. Meals that you might find at Trader Joe's that are fresh. So these fresh meals are like
Yeah.
salads, yogurt parfaits, burritos,
Got
wraps.
it.
You find these at cafes, grocery stores, things like that in the deli section, the fresh food section. Then also frozen prepared meals, right? So this would be Amy's Kitchen and brands like that. Um, Meat packing is made this way. A lot of baby foods are made this way. There's like a gigantic sector of food that nobody
Huge
really thinks
industry. Yeah.
about.
Yeah.
Yeah, huge industries. They're extraordinarily manual. And by the way, one thing that's not obvious is that these are all cold rooms. They're 34 degrees Fahrenheit. So you have people scooping ingredients for 8 hours a day. It's usually two shift operations, by the way. So 16 hours a day, you have humans that are scooping ingredients, and their back is hurting and their arms are hurting, and it's not the best job, of course. So there's a big labor shortage. So that's where
Yeah.
we can come in and say, hey, look, like we're going to help you all automate this process. And again, the whole point is not really to save them money per se. The whole point is, look, I don't have enough humans to do this job, which is basically making me have a lot more demand than I have supply, right? So I don't have enough human labor to meet the demand of food I have. And that's what we can help them do. Basically provide robot workers, if you will, to help them match that demand and increase revenue and volume.
It's
Basically.
interesting. And this gets into like a bigger theoretical question about economics, but we've seen so much inflation over the past couple of years. Obviously, raw input costs are going up, but I also have to think that the labor shortage, if you say 1 million people shortage in food, that's driving in part the food costs. Because as you said, you can't meet the demand with
Yeah.
the product. I'm just wondering if we're starting to see a little bit of that inflation costs come down. I wonder if that's applying more robotics and automation there.
Yeah, I definitely think that there's a part there. I mean, I will say that one of the big things that our customers really value when it comes to food cost is that one thing that the customers really think about is that they want to retain their customers, the consumer, right? You and I. Well, the consumer gets very upset if the label says 5 ounces, but there's actually 4 ounces, or the label says I'll get,
Yeah.
it shows all this chicken, but I actually get way less chicken. So what does that mean? Well, what that means is because the customer, the person who's paying the bills, feels that pressure from their consumer, they tell the line managers to always over deposit. They tell their line managers to always over kind of bias up, right? Because you don't want the end customer to get less food. You'd rather have them get a little bit more than a little bit less. And when food costs are going up and inflation is going up, that's actually doubly expensive, basically, for the company. So one thing that we can do is, of course, because we are using all this computer vision and machine learning, and we also have weigh scales, and I'll show you a video of the robots themselves in a second, but we actually weigh every single deposit we do. What that means is that we can essentially reduce that bias up and reduce the giveaway. That's kind of an industry term here. We can reduce the giveaway to help reduce the amount of wastage. And that's great for the customer, right? Because they're saving money. That's great for the consumer because they can make sure that they're getting the right calories and they're getting the right amount of food. And from a macro perspective, if you can imagine thousands of robots, tens of thousands of robots, I actually think that there could be some more global impact in terms of like warming and things like that. So now that's far away, but I think reducing food waste is actually really important, I would say, generally, for customers, for inflation, for the world.
That's interesting. I mean, we hear a lot about food waste reduction technologies. A lot of the conversation isn't about automation robotics. It's about other things. So that's interesting that you can apply that there. So, but yeah, so I'm kind of we're building up slowly to the news, right? So you guys are
Yes.
basically announcing this Thursday, it's Tuesday right now, kind of having a coming out party. Tell us a
Yeah.
little bit about kind of what you're coming out with. What are you telling the world?
Yeah. So, I mean, I think for the last kind of bit of time, we've been extremely high level. So if you were to look at our websites, any of the
Yeah.
press about us, it's extraordinarily high level. And again, the reason for this is we really felt like we had this like kind of like secret, right? Peter Thiel talks a lot about this. Like, what's your secret? And our secret is that going to restaurants is trying to build the Model 3 from the get go. Like if Elon and Tesla tried to build the Model 3 from the get go, it probably wouldn't have worked. Right? What they did is try to build the Roadster, prove out the technology, sell to a high end consumer. And over time, they built a car that more Americans could afford, the Model S, and then finally the Model 3. I think what's happening in robotics and food robotics specifically is everyone's trying to build the Model 3, which is this at home robot or at restaurant robot, which is going to happen one day. It definitely will happen one day, but it's going to take some time. And first, you got to learn how to manipulate food. That's the hard thing. Food manipulation. How do you not crush the material? How do you get the consistency? How do you get 50 grams and 100 grams or 10 grams, whatever the customer wants? All these ideas. How do you be robust to the edge cases you see in the field? Changes in customer and customer requirements. Like customers like, okay, I want 10 grams now. I want 15 grams now, whatever that is. So we felt like we had the secret with food manufacturing, and we held that pretty close to our chest. Now I think what's changing and allowing us to kind of come forward with that is that I think the world is really waking up to the power of AI. And when it comes to embodied AI, it's all about the data. Everything's about the data, right? Because the more data you have about how to do manipulation, the better your AI. And I think now we've kind of crossed the 20 million meals mark as of only last week. So we just have more data about food manipulation than, at least from what we know, anyone else in food robotics. So we feel like now is a really good time to be like, hey, look, there's this really great problem we can solve. The way you get ahead in food robotics and robotics in general is data. We feel like we have this very smart kind of roadmap, right? Like, let's not go to restaurants. Let's start with manufacturing, high volume, high mix, then go to slightly lower volume, ghost kitchens, and then even lower volume, which is fast casuals and otherwise, and kind of share that news. So that's broadly kind of what we're going to do.
That's great. And when you say embodied AI, for the not uninitiated computer scientist person, what do you mean by embodied AI?
Well, yeah, what I mean by embodied AI is that the AI what most people think, the general world thinks about AI. They're basically talking about large language models.
Yep.
Like, obviously, AI has been around for decades, actually, right? But it took different forms. It took the perceptron, and then deep learning, and et cetera, et cetera. Even SVMs and stuff is arguably AI. Most people think about today LLMs, which is basically this
Yep.
kind of cloud hosted. It's somewhere in a server, and
Yep.
it's like a chatbot that's talking to you, right? I think that's really cool, by the way. I think that really awoke the world to the power of machine learning and AI. I think it's really powerful. What I mean by embodied AI is, can we take that kind of agent, and instead of having it in some server in a server rack somewhere, can we put it into a physical embodiment, like a robot, and have it kind of sense the world, make decisions in the world, and then actuate on the world, basically. And kind of go towards this vision of how do we have robots do the mundane tasks, like scooping food in a 34-degree room over and over, and then have humans do higher value tasks, right? That humans can actually do that robots cannot do. That's kind of
Got it.
that's my belief about what's the most powerful impact of AI.
So looking at what you're announcing, you're coming out to the world, you're kind of having your grand debut. Do we have some videos to kind of look at what this is going to look like?
Yeah.
And
So
for the audio only listeners, we'll kind of try to narrate as much as possible what they're seeing. So
yes. So this is one of our partners. They basically make prepared meals, frozen prepared meals. So you can kind of see this is kind of status quo, right? Which is kind of a lot of humans who are doing this job manually,
scooping
right?
it into looks like what
Right.
paper containers, cardboard containers.
Yes, compostable containers. And now here's the chef robots.
Oh,
So these robots kind of just slide onto existing assembly lines. There's no retrofitting they need. They literally just slide on.
super
Um,
important.
Super important, right? Because again, it makes the sales cycle quicker, it makes the implementation quicker, it makes the risk to the customer quicker or less. And basically each is kind of the same footprint as a human. And essentially it does the same task as a human. So previously there were 4 people who were doing the scooping task. Now, what I want to kind of really call out is that a lot of the hardware you see here is actually off the shelf. It's almost all off the shelf, actually, except these utensils that we actually design ourselves, but then are manufactured by a third-party contract manufacturing firm. And really what we're doing is really adding the machine learning and AI to make these robots flexible. So obviously in this particular moment, you're seeing the robots, and I'll zoom back for a second, or go back for a second. But in this particular moment, the robots are doing rice, right? But equivalently, the robots could be doing diced chicken, shredded chicken, a sauce, a paneer, a snow peas. It could be doing really almost any kind of material you want. And of course, what's hard with that is like food is very highly dimensional, right? If you cut it a little bit differently, if you cook it a little bit differently, like for example, if you have julienne onions in rings versus chopped onions, it's very different physics actually,
Yep.
right? Or if you have sautéed onions versus broiled onions, it's very different. Or if you have onions that you sautéed for 2 minutes versus 10 minutes, it's different. Or Bob did it versus Sally did it, it's different. So, and that's just onions. And there's trillions of different combinations of how you can combine ingredients or cut ingredients or prep ingredients. So how do you deal with all of that variety and complexity without making custom software or custom hardware? That's really where AI helps us. So we can kind of take a lot of off-the-shelf hardware and add a lot of kind of intelligent software and AI to make this kind of hardware flexible so that it can kind of do lots of different ingredients. It can really deal with any portion size you want. So the customer can be like, I want X grams or anything else. It can deal with different containers. Like if you have a clear container, or you have a container with an insert in it, or you have compartments, whatever, you can deal with that. You can deal with different kinds of containers, right? Different customers have different containers. You can deal with different kinds of conveyors. Sometimes you have like a 1-lane conveyor versus a 2-lane conveyor. Sometimes you have a stop and go conveyor. Sometimes you have index conveyors, et cetera. You can deal with all this nuance without making a bunch of custom software and rules, but rather really having AI policies per kind of ingredient. And of course, the more volume of material and ingredient the robot sees, the better each policy gets. And of course, what we're maximizing for, what the system's maximizing for, is consistency. You know, the hard thing is not picking rice. I can make a robot that picks rice in a day. That's not actually the hard part. The hard part is, can you make a robot that picks that customer's rice, how they cook it and how they cut it, and can you be extraordinarily consistent, right? Like within a very small standard deviation. And can you do that at any portion size? And can you deal with all the situational, environmental kind of variances you see? Because of course you're standing next to humans. So humans are pulling bowls out, they're putting bowls in, the bowls are rotated. Each pan of rice or each pan of shredded chicken is a little bit different. It's more different densities, it's different stickinesses, different amount of sauce, so different amount of oiliness. Like that's kind of what we have spent a lot of our time on, is how do you make the system scalable and generalizable for our customers?
Yeah, it's huge. So you did a little bit of work on creating a custom, essentially articulating hand to grab stuff, off the shelf robotic arms, essentially, which results ultimately in lower cost. And then the ability for any sort of situation it goes into to adapt to it, depending on the types of foods and the mixes and new recipes, et cetera, and different CPG customers. So that's how you're scaling. So that's really interesting. And so
yeah,
is the model sounds like it's fairly adaptable and ability to kind of like adapt for the customer. Is it called just Chef Robotics? Do you have a name for your robot?
Yeah, that's a good question. So the software and AI models we kind of call Chef OS, right? And we kind of think about it as like we're kind of building this generalized food manipulation model internally, right? That's kind of, and we're leveraging a lot of like transformers and generative AI to actually do this, specifically like diffusion policies, which is this kind of new technique to like learn from demonstrations, from human demonstrations. So that's kind of the software layer. And then generally our customers, we call the robot just Chef. It's a Chef robot.
Yes, Chef. Yes, Chef.
and yeah, exactly. And what we do spend a lot of time thinking about, by the way, is the user experience and the usability. And the reason I call that out is that one of the things we do in deployment is we kind of do a robot naming ceremony. And that's not by us, it's by the customer. So we'll ship the robots, and usually the plant manager will kind of talk to the staff and be like, look, staff, and of course, a lot more articulate of a manner, but essentially, look, staff, like, we're bringing these robots. I just want to be clear that, like, it's because we have a shortage. Everyone's job is safe, something like that. And this is going to help you do your job better. And you don't have to do overtime because, we're delayed, et cetera. And as part of this, we're going to make you all robot operators. And why don't you even name the robot? So our customers have different, maybe our users have given the line managers, the line staff, right, the line workers have given our robots a bunch of different cool names like Scoopy and otherwise. So it's kind of like they name the robots,
Scoopy.
and it makes them feel like it's
Some
theirs.
ownership. Yep. Some investment in
Yes,
it. That's
yes,
great.
yes. Which is really critical, by the way, for deployments, I would say. Like when you're deploying real robots into customer sites, they don't care about the AI. They don't care about anything. They don't care about the technology. They just care that it adds real value. It's easy to use. If something happens, they can really easily understand what's happening. They can kind of understand the robot, things like that.
That's great. All right. Well, Rajat, we have just a couple minutes left. Before we go, I just want to ask you, are you naming any customers or in the announcement, any kind of people you could talk about?
Yeah, so there's a few customers we'll be announcing. So one is Amy's Kitchen. They're kind of a large frozen prepared meal company we work with. They were actually one of our early design partners. Sunbasket is a direct-to-consumer meal provider. They also make meals for other brands now. So they have a big contract manufacturing arm. So they'll make a lot of meals for lots of different brands.
Grocers or other.
Yes.
Yep.
Grocers, D2C brands, prepared meal brands, frozen prepared meal brands, etc. And then we're also finally announcing Chef Unveils. So this is one of our customers in Canada, and they basically are a big contract manufacturer. They also have their own kind of brand, of course, the Chef Unveils brand. But a lot of their business is actually contract manufacturing as well. So these are some logos that we've kind of worked with. And as of right now, what's cool is that we actually have robots now in 6 cities all over North America. So, we've been very quiet, but I think we've secretly, done a ton of volume. I mean, we manipulated thousands of ingredients in a bunch of different parts of the country and Canada. And now really it's kind of like, hey, we have a really good set of current customers who are big customers, right? These are large corporations. There are a couple other logos we can't name, but kind of a really large player in the fresh prepared meal brand and a really large player, one of the largest in the prepared meal, like prepared meal delivery brands. So we have a few really good customers, and of course, scaling within those customers and also kind of scaling with net new logos is kind of our big focus right now. And over time, what we'd like to do, of course, the vision of Chef is really how do we deploy robots in food facilities generally, right? Not just food factories, not just food manufacturing, but general kind of food facilities. And I think we'd like to, very much kind of similar to the Tesla kind of execution plan, like kind of go to lower volume environments. So I think we're going to start kind of really seriously considering some of these delivery only operations in the short term.
Well, the lowest volume market in the world is the home. Any like 10-year plan to get a chef in the home?
It's really interesting actually you asked that question. I am kind of the opinion that at-home robots for food will not be a thing.
Okay.
And I'll give you a very quick kind of anecdote of why. So, when I was first starting the company, I actually thought about at-home robots. That was my first kind of impression. Like, let's have a robot in your house. So what I did is I went and I did a little thought experiment with my friends. And I was like, okay, look, option A is a robot in your house, and it can make you anything you want. Okay, so that's option A broadly. I don't know how it's going to work yet, but let's just say that's option A. Option B is imagine a future where you have ghost kitchens, you have robot delivery, and then you have robot chefs in kitchens. So what does that mean for you, right? What that means for you is the cost will be much lower because ghost kitchens reduce the cost of labor. Ghost kitchens reduce the cost of real estate. Robot chefs, like Chef, reduce the cost of the labor, and then delivery robots reduce the cost of delivery. So basically, imagine it's at parity with having this robot at your house, and maybe even at parity with cooking. So that's better. 2 is you can keep your favorite brands. People really like their brands, so you can keep that. And 3, you can basically customize it because robots are really good at customization. So you can customize your meal just as if you were to cook at your house. What I learned, what was interesting, is every one of my friends picked option B, which is very interesting. Nobody wanted to, and I asked why, and people said things like, I don't want to have to maintain this robot in my house. I don't want to have to buy the thing. I don't want to have to refill it. I don't have to take care of it. And I actually really like this idea of having to be able to rent the food, if you will, just get the food delivered. It's kind of like, back in the day, well before either of us were alive, people used to make textiles at their house, right? And then at some point, people said, hey, why don't we create a factory and outsource textile manufacturing to a factory? And today, very few people make textiles. Some people still do, right? But like if you talk to the average American, like 80%, like there's some a New York Times article about this actually I read. It's like 80% plus of Americans do not like to cook at their house. So my kind of belief is what will happen is that cooking will go to people will still cook who really want to. Like there's some people who love to cook, amazing. But I think more and more of the world will get their food kind of made in a ghost kitchen by a robot, delivered by a robot.
Yeah.
And it's not going to be like a prepared thing like we're doing right now. It will be kind of fresh, but it'll still be this kind of pick and place operation to maintain the flexibility. And they can kind of customize it on like whatever, if we're using Neuralink at the time, Neuralink, but a DoorDash app for now, basically.
That's an interesting feature. I'd love to spend another hour talking about it. Maybe we'll have you back on the podcast, Rajat, to talk about that.
Great.
And so, but I really appreciate you spending time. Like I said, I've been following you for years now, so it's great to see you guys come out and sharing the news. And we'll be out with this news on Thursday when you guys break it to the world. But congratulations on all your success.
Yeah, thank you, Michael. It's been great to stay in touch, and I really appreciate the work you're doing to kind of foster this community, and like food tech and robotics and food generally is really awesome.
All right. Thanks, Rajat.
Thanks.